In this example, we're going to use the disk method to find the volume of the solid generated by revolving the region bounded by this curve, y equals the square root of x, and also bounded by the lines y equals 1 and x equals 4. And instead of rotating it about the axis, we're going to rotate it about the line y equals 1. So, a couple things. First thing, it says we want to use the disk method. So if we're going to use the disk method, we need to know our disk method formula. And that volume is found by the integral from a to b of pi times whatever we determine our radius function to be squared. And when we're using the disk method, right, and we're rotating about a horizontal line, so we're going about y equals 1, that means we would need our variables in terms of x. Now, if we were rotating about a vertical line, say this had been x equals 1 in this direction, then these variables would need to be y. And we would refer to those as C and D. But that's not the case here, so I'm going to erase that. So let's think about what our graph of this square root function looks like. What is the space that we are rotating? So the graph of a square root function looks roughly like this. And of course, in this situation, we have the line y equals 1. And we also have a line x equals 4. So that means we are taking this region enclosed here. All right? And we want to take that region and rotate it about this line, about the line y equals 1. So ultimately, once we do that, we'll have this cone-like shape here. All right? So what is this point where these two lines are intersecting? And we know that the point 1, 1 is on the curve right there. So that means my x's are going to go from x equals 1 to x equals 4. Those are going to be my a and b values. So setting this up, we would say v, my volume, is the integral from 1 to 4 of pi. And we have this radius squared. And we need to think about how to refer to the radius. Remember, because we're going about a horizontal line, we want everything in terms of x. So what is my top radius and what is my bottom radius? And so if we were to set this up, we would end up with the square root of x minus 1. That is the radius. That's this vertical distance here. It goes from 1 to the square root of x. That difference creates this radius. Once we've done that, this is a fairly easy problem to solve. I'm going to pull this pi out in front. I'm going to FOIL this so then I can use my power rule. All right, we don't have to do any substitutions. So I have pi, the integral from 1 to 4. If I FOIL this, I end up with x minus 2 square root of x plus 1. When we're dealing with the square root of x, we often write that as x to the 1/2 power. So at this point, we would just use our power rule. And that would become, this first term would become x squared. So we've got x squared over 2 minus 2. This next term, when I add 1, is going to be 3/2. So we have x to the 3/2 over 3/2. And dividing by 3/2 is the same as multiplying by 2/3. So I have 2/3 x to the 3/2. And then the integral of just 1 would become x. So we need to evaluate that between 4 and 1. I'm going to plug in 4 first and then 1. So looking at this with 4, leave my pi in front. I I have 4 squared over 2 minus 4/3. My x is going to again be, we'll have 4 to the 3/2 plus 4. So now we'll do the same, plugging in 1. So minus whatever this quantity will be. I have 1 squared over 2 minus 4/3 times 1 to the 3/2 plus 1. So as I look at simplifying this, I have pi. I've got 16 over 2 is 8 minus 4/3. If we think about 4 to the 3/2, you square root 4, you get 2. 2 cubed is 8 plus 4. I would have minus 1/2. That would become plus 4/3 and minus 1. And if I add all of those together, I will end up with 7/6. So my answer here is 7 pi over 6. And so I paused the video and I brought these two pictures in. This first picture right here, this is the shape, right? It's just kind of a cleaner version of the shape I drew up above. And we want to keep in mind that we were looking about rotating that about this line y equals 1. And so this was the conical shape that we created. And the volume of this cone is 7 pi over 6. And I just like to bring the picture in from our text because it makes it a little bit easier for you to visualize what we have just found. So we found the volume of that green region. So that concludes our video of using the disk method to find the volume of a surface when it's rotated about a line which is not the axis.